This video is about how we would use quadratics to help us answer some questions. We would call this quadratic modeling, and we're going to deal with one specific type of question about maximizing area in this video. So we spent so much time talking about how we graph quadratics. How would we use them in the real world? Well, you might need one day to build a fence for your pet chicken. And you might decide that you want to save some fence and use one of the walls of your house as part of the barrier for your chicken. And that way we'll only need 3 walls for your fence, as shown in this picture. So you can see we have a fence wall here, here, and here, and then our last wall is really just to the side of the house. So what if we only had some amount of fencing, in this case 40 feet of fencing, and we want to find the maximum area we can create for the chicken. So we want to maximize the enclosure space, maximizing the area. Well, one way of starting this problem is by calling one of the sides x in this scenario. And I like to pick one of the sides that there's 2 of. So notice there's a top side and the bottom side is also congruent to that. So let's call this top side x, and that's nice because then we know right away that since we have a rectangle, this bottom side is also x. Remember, we only had 40 feet of fencing to start with. So we've already used x plus x is 2x feet of fencing we've used. So we have 40 minus 2x feet to use for the remaining side. We want to use all the fence that we have. We know we have to use all our fence if we're trying to maximize area. Now we've come up with a rectangle where we have names for the dimensions. One side is x, one side is 40 minus 2x. We can get an expression for the area of this rectangle. We know that area of a rectangle is length times width, or x times 40 minus 2x, length and width. What I did in this last step right here is I distributed that x in to the 40 and the negative 2x. So now we have a nice area expression. That area is equal to 40x minus 2x squared. Notice that is a quadratic expression because we're talking about area. That would make sense that we would have an x squared term. What we're trying to do is maximize area. So it might be no surprise that we're trying to find the maximum of this function. Notice in the second line down, I just reordered the terms so I could see that my quadratic term is negative. That would mean that the parabola opens down. That would mean that parabola has a maximum, which is good news because we are trying to maximize area. Luckily, we know how to find the maximum of a parabola. We can find its vertex. And we have a nice shortcut to find the x value of the vertex. That's that negative b over 2a piece that we investigated. So if our vertex is at negative b over 2a, that x value, that would be negative 40 over 2 times negative 2, which gives us an x value of 10. So we're not done yet because that's not the area. That's just the x value. What does that even mean? An x value of 10 would maximize area. Well, remember what x stood for. X was one of the sides of our fencing, the area that we've enclosed by our fence. So when that value is 10, that's what maximizes the area. We have a couple of ways to find the actual maximum area. We can plug in to our area function, negative 2x squared, or negative 210 squared plus 40 times 10, and we get that 200 feet squared. That's our maximum area. Another way of finding our maximum area is by plugging in to find our dimensions. One dimension was 10. The other dimension was 40 minus 2 times 10, or 20. So the dimensions of our enclosed space is 10 feet by 20 feet. And there you can also see that if we multiplied our dimensions together to find the area of that rectangle, we would in fact get 200 feet squared. So we developed a quadratic that we used to model the scenario. And then we had to find the maximum of that quadratic in order to get the maximum area. And notice we were also able to find the dimensions for our fence. So there's one example of how we would use quadratics in the real world to answer questions about maximization. Good luck!